Hello, everybody. Welcome to the last day of ChapelCon 25, as Brandon just welcomed you. I'm Brad Chamberlain. I am the technical lead of the Chapel project, and I'm one of the founding members of the project. And this is something that we have done every year that we've had ChapelCon and Chew before it, where I've had the opportunity to kind of...
Gonna eat, and then
Uh,
give me a ride.
okay, where I've had the opportunity to kind of take a look back since the previous ChapelCon or Chew and talk about highlights since that time. And usually this has been on an annual basis, but with a shift in schedule this year, this will be more like a 1.5 year overview. This is one of my favorite parts of the year because it's really fun to see how much we've accomplished in every given year, or 1.5 years in this case. All right, so let's dive right in. I've got sort of 4 major sections to my talk today. I'm going to start out with a summary of some of the technical progress that's been made since last year's ChapelCon. I'll then talk about community updates and news, kind of exciting things that have happened in that time. Talk a little bit about Chapel and HPSF, which is the High Performance Software Foundation. And then I've got a few closing thoughts before we wrap up. So when I was looking back at where were we last year, just to kind of remind myself, one of the things that was a big deal last year and still is a big deal was Chapel 2.0. This is something we presented on last year at ChapelCon. It was a milestone release that was done in March 2024, and the 2.0 was an indication that this was the release where we considered the core language and library features to be stable, which is to say if you were using those features in your programs should not break from here on out. Since then, we've continued doing our releases on a quarterly basis, which is what we've been doing for the past few years. So we've done 6 releases since we last saw you. And that's gone pretty smoothly, about as smoothly as releases ever go. And really appreciate all the effort from the team and the community to get these out and to have each one contain new features and improvements over the last one. The links here in these announcements are to the release notes, and that's where you can read more about some of the highlights in each one of those. And obviously the links won't work till I share these slides, which I'll do afterwards. So happily, since that 2.0 release, stability's been maintained. We have fixed many bugs, which we reserve the right to do, and probably you'd like us to do. We've also added new features that don't break existing features. In addition to those things, we've added a way to try out new breaking changes. So with 2.0, we didn't have any illusions that everything was perfect, and there wouldn't be anything we'd regret as it was. But the goal is to not sort of make those breaking changes until we get to like a 3.0 release, for example. In the meantime, what we've done is add Chapel editions, which are a concept we've borrowed from Rust, where you can basically opt into a given edition to opt into features that would change the behavior of an existing code. So for example, today we have an edition called the Preview Edition. If you enable this, you get some new behaviors like the old reshape becomes a reshape operator on arrays that aliases the original array's data, whereas before it always copied. We improved the printing of complex values that have NaN components in them. And we removed a sorted iterator on domains, which we meant to remove for 2.0 but failed to. And so being good to our word, we are only removing it in this edition. From here, I'm going to go into some of the language and library highlights that have been made since 2.0. Again, we can still add things to the library and language. We just can't break existing features. And so I've pulled out 4 key language and library features that have gone in since last year, or areas we've worked in. The first is support for remote variable declarations. This is a feature that has been, I think, in the language spec since we first wrote it, but has never been implemented till now, where you can say on some remote locale, declare this variable. And so without moving my task around, I can declare variables in arbitrary locales. And the really nice thing about this is, while you could do this before, you always had to introduce a new lexical scope such that when that scope exited, the variable would go away. And this allows you to inject new variables within your current scope, yet on remote locales. A second thing is we've added support for multidimensional array literals. This is something that's been on users' wish lists for, I think, well over a decade now. We're using the semicolon as kind of a dimension break. Single one gives you a 2D array, multiple gives you higher dimensional arrays. And so here I've shown a little 2x3 2D array. The line feed here is merely a stylistic concern. You don't have to use it, but I like it from a clarity perspective. The third thing is we've continued work on GPUs. In the last 1.5 years, we've improved their performance, their flexibility, quality of life, and portability. And the last one's something of a work in progress, but I think it bears talking about. Since Chapel's inception, we've had the notion of having sparse domains and arrays, and we've had sort of a prototype implementation of them, but they've never really gotten a lot of attention. And so with 2.0 behind us, we've started to be able to invest some time here to add in some new queries, some new capabilities, some new optimizations. I want to emphasize work definitely remains here, but it's been gratifying to see these features start to get attention after many years of neglect. And we'll actually see a little bit on sparsity, I think, today in Oliver's talk later on. The talk is primarily about this aggregation framework that Oliver's been working on, but one of the motivators for that has been some sparse matrix computations. And so while we won't see everything that's happened here, I think we'll see a flavor of sparse later on today. In terms of library modules, our sort module was not part of the standard modules at the time we did the 2.0 release. We have since gone through and stabilized it, promoted it to a standard module. We've also added a fast, new, scalable, distributed sort routine, and that's been really impressive to see some of the performance results on. And we'll be seeing some highlights of that in a couple of talks later on today. Then we've added 3 new libraries that really caught my attention when I was looking back. There's the Python module that supports calls from Chapel to Python. Jade and Lydia will be talking about that later on. There's a dynamic loading module that allows you to call from Chapel to dynamically loaded C or C-like libraries. And there's a new image module that lets you read and write image files from Chapel. Okay? There's been a ton of other great stuff as well, but again, sort of from a headlines perspective, these were 8 things on the language library front that caught my eye. Now, tools has been an area we've invested in a lot in the last couple of years. Sort of as the 2.0 effort has wrapped up, it's been a good chance to kind of go and flesh out our tool story a bit more than we've had the chance to before. So starting out with coding tools, I'll call out a couple of things. In VS Code, we've added task providers, which give you sort of a nice way to compile or run or debug your Chapel programs. Then within the ChapelCheck linter, which has existed for a little while, we've added new rules, we've documented all the rules, and we've improved the ability to add new ones. Now there's a bunch of other tools related to coding, our documentation generator, language server for editor intelligence, Python bindings to the front end, our package manager. These have all received a lot of improvements as well. It's kind of a bit of a laundry list. So I didn't kind of call out specific things, but all of these are getting used by the team more and more and being improved based on that usage. Hopefully some of you are using them as well. And then finally, Dino, which is our new front-end compiler rework and library, basically taking the research prototype that I and the early colleagues on Chapel did and rewriting that in a production-grade implementation. Over the last year and a half, it can now resolve and lower much more of the language than we could at ChapelCon 24. And often, it's much more correct. So we'll get users submitting bugs against the compiler, and we'll say, well, I wonder how Dino does with this. And often, it gets it right where the production compiler didn't, just by virtue of being sort of a fresh implementation and done sort of understanding the language definition much more, whereas in the original implementation, we were still figuring that out as we went. I should also mention Dino powers almost all of the tools mentioned above, so it's really crucial from that perspective as well. In the last 6 months or so, we've turned a lot of attention to debugging, which is something that really hasn't had a very good story in Chapel in the past. And a couple of high-level bullets here. In general, we've just improved the code that we generate from LLVM in order to just pass more better debugging information back to debuggers. We've improved support for Chapel within address sanitizers, and we've improved our documentation about debugging to capture best practices better than we have in the past. But there are also some other cool things that lend themselves well to some pictures. So let me just describe those with these pictures. In LLDB, before this most recent release, when you printed out Chapel data types, you would sort of see the underlying C implementation, which isn't really very intuitive to a typical user. We've now added pretty printers for LLDB such that when you print out things like the strings, domains, or arrays shown here, you get a much more intuitive view of that data structure. Within VS Code, we've integrated debugging support. So here you can see I've chosen to debug my example. I've hit this breakpoint here on this right line, and I can see the user level variables here on the left, including the pretty printer being invoked here on this array. So nice improved support for VS Code. And then the last one is a brand new prototype debugging mode for multi-locale runs. And this is all done within a single shared console, essentially. I'm not going to walk you through this because there's a lot here, but I want to call out just a couple of lines here that use this custom on command. And this allows you to change the debugger's view from one locale to another using its ID. And then you can see things like, well, where is this locale's stack frame? Or what does this locale's version of the variable look like? And then you can use the on clause to switch to another locale and check things out there. Again, this is still in early days. There's more to do to improve this and clean it up for sure. But I think this is very exciting compared to the status quo we've had, which is to launch a window per locale. The last thing I think I'm going to touch on in this section is packaging and portability. This is not the most exciting thing unless you're trying to install Chapel and it's just really hard or you don't get what you want. So I think it's worth mentioning. We have a new Chapel SPAC package and also a pair of packages for Arcuda for those of you that use it. If you're not familiar with SPAC, one of our invited talks later on today is going to be Todd Chamberlain, one of the founders and PIs of SPAC, and so you'll hear more about it then. For those who use Linux packages, we have fleshed out the Linux packages we supported a year and a half ago to add many new configurations. Well, I should say many new platforms and new configurations, even for the existing platforms we had before. We've made many improvements to the Homebrew release for those of you who are Mac or Linux Brew users. We've improved support for AWS over EFA. And we've also improved access to the HPE Cray EX RPM, either using GitHub or my HPE Software Center. So lots of ways to get Chapel. Hopefully we're making it available through the ways that you need the most. But if you find something missing in this portfolio, please let us know if it would be useful to you or your users in making use of Chapel. All right, that wraps up kind of my technical summary from the past year and a half. Let me move on to things that are cool in the community. The first one is, if you haven't noticed, we have a new website since ChapelCon 24. We launched it at the beginning of this calendar year. It has a lot of improvements. It looks more modern and sort of what you might expect from a modern language website. It also renders much better on mobile devices, which our old one was terrible at. And for those of us maintaining the website, it's much, much more maintainable than it used to be, which is amazing. The website's GitHub repo is now public as well. So if you see things that you could improve or help with on the website, we've got a bunch of issues open. That's something the community can contribute to as well now. We also have a new Chapel newsletter. This was launched in August of last year. And Engin's been editing this and pulling it together, which has been really, really great. On a quarterly basis, this gets published, and we sort of roll up highlights and talks and announcements and things from the previous 3 months and upcoming in the months to come. So if you want to check this out, you can browse or subscribe to it through Discourse. We also launch announcements of this on our social media channels, so that's another way to know when new editions come out. Speaking of our social media, in the past we've had LinkedIn, X, Mastodon, and Facebook as our main channels. Since then, we have started posting regularly to Reddit, to our Chapel. We've started a new Discord server, which has become the primary way that we communicate in a chat-based mode with the community. So if you'd like to chat with Chapel developers or users, that's the place to go. And then we've launched a Blue Sky account as well. That was at the beginning of this calendar year. So if you use any of these platforms, please follow us there. We tend to average about 2 to 3 posts per week on average. I think we've maintained that over the past year or so. And we always appreciate when people like and repost things. That's how we help spread the word. That definitely helps us grow our community. One of my favorite things from the past year and a half is that we've launched a new blog series called 7 Questions with Chapel Users. These are interviews with Chapel users where we ask them, what are you doing in your science? And how are you using Chapel? And how has it helped you? And how has Chapel been frustrating to you as well? So if you're interested in hearing more about user perspectives, or you know people who'd like to read more about how it's used in oceanography or computational fluid dynamics or data science, this is a great place to point people to and a great sort of gentle introduction to Chapel and its use. Also mention this is an ongoing series, so if you are a Chapel user and you think you've got an interesting story, contact us. We'd be happy to add more additions to this series as we go. Speaking about the blog more generally, in the 70 weeks since ChapelCon, since ChapelCon 24, we've published 33 new articles. That's about 1 every 2 weeks, which is what our general goal has been. We've done both new series and a bunch of standalone articles. Just to call out some of the new series we've done, I already mentioned the 7 Questions series. We did a 4-part series about doing Navier-Stokes in Chapel, which is really great. It took an educational Python Navier-Stokes code, transliterated that to Chapel, compared the two, and then also compared to MPI and OpenMP. And then I've been working on republishing a series that I originally wrote 13 years ago. It's been out of print since then. It was called 10 Myths of Productive Scalable Programming Languages. And this was done when Chapel was still in its infancy. We didn't have very good performance or scalability yet. Things have changed a lot since then. And as I said, the series has been out of print. So this year I've been republishing that and adding modern commentary, sort of like, okay, 13 years have gone by. Do we still believe this? Do we believe it more? Do we have new evidence that what we were arguing is true? And you can think of this as sort of taking a lot of the criticisms or doubts people have about doing new programming languages for HPC or parallel programming in general, and rebutting those claims essentially. Over in the standalone articles, I wanted to call out some of my favorites. Michael Ferguson did one on memory safety in Chapel, comparing to Rust, Python, C, C++. The takeaway there is that while Rust gets a lot of the attention for being a very safe language, Chapel is a very safe language as well and has a nice mix of productivity benefits in addition. Daniel did one about using Gen AI to write and refactor Chapel. This was really interesting, particularly for me as someone who's a little bit of an AI skeptic. Andy Stone did one about writing the billion-row challenge in Chapel, how the performance and the productivity compare to other languages and approaches. And then we've had other ones on using Chapel on a Windows gaming GPU, interoperating with Chapel and Fortran, doing hyperparameter optimization, using Chapel's Python bindings, a report from SC24. A real mix of topics, and if you're not following or reading the blog, I think there's a lot of amazing content there. I would definitely encourage you to check it out. We've launched a number of new community events this year. I'll mention a couple of the key ones. First, we started a monthly Chapel demo series that was launched in July of last year, and those are recorded and archived on YouTube. This is a great place to check out a little demo on how do you do this or how do you do that, or even just to learn about things that you didn't even know maybe you wanted to learn about. Michelle Strout, around the same time last year, launched a new Teaching in Chapel meetup. This is a monthly meetup for people who are interested in teaching Chapel in courses or in standalone tutorials. At some point a few months ago, she handed that off to Alex Razumov, who has very gracefully been taking it up since then, and we really appreciate that leadership there. And as part of this effort, we've launched a new GitHub repo called Chapel Examples and Teaching Materials. If you are someone doing education tutorials or just looking for code examples, this is a great resource to go check out. Finally, we launched monthly office hours, though since then we've folded them into other weekly meetings that I'll talk about a little bit later on. Needless to say, if you need some of our attention and time, there are now opportunities to drop in on a weekly basis and talk to us. One of the things I like to do in these annual updates is to see if we have some new PhDs who have written dissertations using Chapel. And this year I want to congratulate Dr. Oliver Alvarado Rodriguez, who graduated from NJIT under David Bader. His PhD dissertation was called On the Design of a Framework for Large-Scale Exploratory Graph Analytics. This was done within the context of the Arachne project and the Arcuda framework. You can read his dissertation online, and I'm very pleased that Oliver has joined us at HPE on the advanced programming team. One other thing I normally do in these talks is I list some of the highlights in terms of talks or papers and things from the year. This year there were so many, it just was almost too hard to do. I ended up putting together the following list, but I filtered out of it like all of our Chapel 101 talks, which we do a lot of, or our CUDA 101, or Chapel on GPUs. So these are sort of things that stood out as being kind of different from just the traditional Chapel talk. From Paul Sathry's amazing ChapelCon keynote last year, which remains one of my favorite Chapel talks of all time. Definitely recommend you check that out if you haven't seen it. To a number of papers and talks from members of the community, members of our team. Most impressively to me when I looked through this was not all the different things we'd done in the past year and a half, but the diversity of names and affiliations that showed up here. So we really appreciate all of you in the community who have helped kind of spread the word, whether intentionally or unintentionally by just promoting your own work. It's really great to see all this work going on, and we're really invigorated by everything you do. If you'd like to browse this list or other things I couldn't even fit into this list in more detail, again, the newsletters is a great place to turn to get that information. So at this point, I want to talk to turn my attention to HPSF. I'll define what that stands for in a second, but I want to start with a little bit of a historical anecdote. I don't know how many of you may have known Burton Smith. Burton was a mentor of mine in my academic career and in my early professional career. When I joined Cray, he was the chief scientist here, and he was the co-founder of Terra Computing, which purchased Cray from SGI and adopted the Cray name at that point. And important to my career is that I was hired to work on this HPCS program called Cascade, which is what led to Chapel. Chapel stands for the Cascade High Productivity Language. And Burton, as chief scientist, was the PI of this program. Now, in this program, I was initially hired to do software productivity. My goal was, how do we make users 10 times more productive on supercomputers than they are today? And I came out of grad school as a proponent of programming languages and language design for parallel computing. So at some point in October, I walked into Burton's office and said, hey, I think to improve user productivity, we should create a new language. Probably not surprising. He probably could have guessed I might have said this. And he said, no, I don't think we should. His worry was that a new language developed by a single vendor would never be successful. And at that time, I was pretty fresh out of grad school. I definitely held Burton in high esteem. And so I kind of left like, okay, I'm kind of sad, and who am I to argue with Burton after all? But I thought about it over the coming weeks, and I went back in November, and I was like, but wait, several important languages have obviously started with a single vendor, whereas sort of C and Java were two key examples that I think I had in mind at that time. And Burton's a very open-minded kind of person. He's not going to like stick to a position just for the sake of, argument. And he said, good point. Let's do a thought experiment. Let's think about the languages we care about and where did they come from. And that led to this slide that I've intentionally made small here so we don't get bogged down in it. But we sort of looked at languages we cared about and sort of their predecessors and where they evolved from. And the conclusion was a lot of things really do start out with a single vendor. And so after that, he said, okay, let's do a language. And he noted that a lot of successful single vendor languages, in order to become successful as they are, basically at some point made a jump to a community governance model. And I'm telling you this whole story because what I'm trying to say is from that first day that Chapel was launched, it was our intention to make it eventually be a community governed project. And this is something we've explored from time to time over the years and been kind of daunted by because we didn't know much about starting a foundation or an open source group or anything like that, but it has now happened. And so that's what I'm here to tell you about today. So if you're not familiar with HPSF, it stands for the High Performance Software Foundation. It's a neutral hub for open source HPC software. It's part of the Linux Foundation, so it's sort of a sub-foundation within the Linux Foundation. And its mission is to constantly improve the quality and open availability of software for HPC through open collaboration, focusing specifically on performance, portability, and productivity. And the goals for member projects, which is to say projects like Chapel, are to increase adoption of HPC, aid in HPC community growth, and enable development efforts. Now, if you look at these mission statements and goals, they correspond really heavily to what Chapel's been trying to do all this time. Get new users onto HPCs, make it easier to write applications, get performance and productivity together. So this just felt like a natural fit. And for that reason, we decided to look into applying. As I said, we've always intended to move from a single vendor model to a community governed model. This is a chance for us to network with other open source HPC projects and share best practices. Maybe we have experience that they could benefit from. We definitely have a lot to learn ourselves. And we anticipate that this could have benefits to Chapel's visibility and stature, just being part of a larger group and organization in the Linux Foundation specifically. There are a number of sponsors of HPSF, including Hewlett-Packard Enterprise, the employer for people on my team. You'll see a bunch of other corporations, labs, and universities that you recognize on here as well. So this has been very exciting to see this list grow since it was originally launched. And then in terms of the projects that are involved, I've listed the founding projects here, where certainly the presence of HPC Toolkit, Cocos, SPAC, Trulinos were things that caught our eye and drew us in. Since those original founding projects, OpenCami has joined as well. And I believe there are others as well that are making their way into the organization. These were the ones on the website when I made this slide. So our timeline was we first started hearing about HPSF in November of 23 and May of 2024 when it was officially announced. Last fall, about a year ago, a little bit longer, the first applications started getting submitted. We were encouraged to apply if we wanted to, which we did. And so we submitted our application in October, just about a year ago. The beginning of this calendar year, we presented our application. A couple weeks later, learned we were accepted. And that kicked off a legal process that has been going on more or less ever since, both at HPE and Linux Foundation, to actually do the due diligence, to kind of do the transfer and make it all proper and legal. In the meantime, we've been working on making a number of aspects of our project more open than they had been. We've had weekly projects meetings forever. We've made those now open to the public. You can join us for our weekly meetings and kind of see how the sausage is made. As I mentioned earlier, we made our web repo public. We then took our deep dive meetings, which are on Thursdays, and made those public. Those are designed to be an open meeting that from week to week can be used for any discussion topic or code review or whatever you'd like. So you can propose topics to that if you would like a longer slot with the team talking about something. And then in July, we made our blog repository public, where it had been private before. Just about a month and a half ago, we formed our initial technical steering committee. This is like the board of directors for the project, if you will. It's basically made up of Chapel developers and people with merge privileges. And then just in the past few weeks, we've finalized the technical charter, held our first TSC meeting, approved it, and signed the paperwork that legally transfers the Chapel name and accounts over to the HPSF and Linux Foundation. So this is huge news. This has been a big thing for the past year, and we're very excited to have just recently crossed this finish line. If you feel surprised you haven't already heard about this, assuming you haven't, the reason for that is we're planning on doing a big publicity announcement jointly with HPSF, Linux Foundation, and HPE. Ideally, we'd like to do this in time or maybe at SC25, sort of a logical place for making big announcements. The big thing that's holding us up is that we were not able to transfer our traditional logo over to the Linux Foundation, so we need a new logo. We've opened some issues about this. Some of you may be following those. What we're looking at right now is, can we quickly crowdsource designs in the next week or so, I think it's going to be, in order to hopefully get that logo approved and designed and the announcement out in time for SC. So we're trying to keep this moving. If you're interested in being part of this, please check out the issue and follow along. Thereafter, we've got other things that we need to open up. The TSC is meant to be an open committee. We need to determine how you apply to that. And we also need to, over time, determine how to add new project committers and mergers and what the security implications of that are. All right, I have run out of time, so I'm going to skip past this. This is a little motivational thing about how Chapel has sort of persisted through massive hardware changes that have made HPC more complex. We'll have to find another time to give you that pitch. You can read through those slides on your own. I also have a quick thing I want to say about AI and Chapel and languages in HPC. I think a lot of people think that now that AI can program, do languages like Chapel still matter? If you're not writing the code, do you care if it's more productive? And my answer is a resounding yes. To say we no longer need good programming languages and compilers in the age of AI is like saying we no longer need to invest in roads or automobile manufacturing or fuel efficiency, safety, or traditional driving skills in an age of self-driving cars. The presence of this new technology doesn't remove the need for improved ways of doing things. The value proposition here is that humans will still program, yet even if AIs are doing most of the programming, I think higher level clear languages will enable greater AI successes. And in cases where users have to look under the hood and see what the AI is generating, the more comprehensible the code is, the better. So I think Chapel still matters a lot in an age of AI. Wrapping up, I hope you've seen that a huge amount of progress has been made by the community at large, as well as our team at HPE since ChapelCon 24, and we're very much looking forward to what the year ahead holds. And I look like I have about 3 minutes for questions, which is 2 fewer than I was hoping, but I'd be happy to take questions if there are any at this point.
Awesome. Thanks, Brad. And everyone's already giving the round of applause. Wonderful.
Yeah, so any questions? Such silence. I could go back and do those slides in 2 minutes, but I probably couldn't, so I won't even try. I will say that those slides I skipped past are from a keynote I gave this summer at the 30th anniversary edition of HIPS, which is a workshop for high-level programming languages. And basically what I did was reflect back on the past 30 years of HPC. How has the hardware changed? How have the programming models changed? And the sad thing is the programming models that are broadly adopted generally have not changed much at all, apart from the advent of GPU computing. Luca, go ahead. I see you have a question.
Yeah, hi. I have a quick question. So, what do you hope to be able to say next year in your status of Chapel? Like for ChapelCon 2026, what is that you hope you will be able to say in next year talk?
That is a big question that I have not thought about at all. Let's see, off the top of my head, I've mentioned a couple of ongoing things that are very much of interest to me: the sparse computing, the debugging, and Dino are sort of 3 things that have been ongoing that I would really love to see pass some major milestones in the coming year. For sparse computing, we've been looking at some sparse linear algebra routines like sparse matrix multiplication. I'd love to have a great demo of that and some performance comparisons against alternative technologies. For Dino, we've been working on getting more and more of our testing suite through Dino. I would love to say that the Dino front end is the default front end a year from now. I can't say how realistic or not that is, but I think it's an amazing goal for us to work towards. And debugging, I guess, was the third thing. Debugging, as you saw, the sort of multi-locale story is just starting to come together. I think given how important that is for Chapel and how difficult distributed memory debugging is in general, that getting that prototype tool to a better stage will be a great thing to try to have happen in the coming year. I don't know if those are the top three things, but off the top of my head, those are three that quickly come to mind. And hopefully, obviously, I hope a year from now we're like super excited that the transition to HPSF has happened and has been just a positive experience. I have high hopes for it, and I hope that those will be met. Yeah.